Hello, and welcome to this video where we're going to go through a selection of AQA exam questions on the topic of sequences. Right, first question. Here are some numbers: 10, 13, 15, 20, 27, and 39. We're told that 10, 15, 20 is an arithmetic progression, meaning that it goes up by the same number each time. So this particular progression here is adding 5 every time. We're being asked to use 3 of the numbers from the list to make a different arithmetic progression, and then also say what the rule is, so describe the rule. There's 2 possible answers for this. You could have 13, 20, and 27, in which case the rule would be that we were adding 7. Or the second possibility is that we could have 15, 27, 39, in which case the rule would be add 12. Question 2. Here is a number sequence: 31, 26, 21, 16, and 11. What is the next term in the sequence? Well, if we follow the pattern, each of these numbers is going down by 5 each time. So if we go down from 11, so 11 minus 5 is 6. So 6 will be the next number. Part B is writing down that rule, so we are minusing 5 each time. And part C says what is the first negative term in the sequence. So if we carry the sequence on, from 6 we go down by 5, you'll end up at 1. And from 1 you'll go down by 5 to minus 4. So minus 4 is the first negative term in the sequence. Question 3. The nth term of a sequence is 5n minus 2. Work out the third term. The n inside the nth term is the term number. It's the position in the sequence. So if we want the third term, then we are making n equal to 3. So 5n means 5 multiplied by n, so that's 5 multiplied by 3, then subtract 2. 5 times 3 is 15, then when we take 2, we get 13. Question 4. The first 4 terms of a linear sequence are 3, 11, 19, 27. Circle the expression for the nth term. When we deal with nth term, the first part, so when you're looking at the 5n, the n, the 8n, and the other 8n, that is what times table this sequence is based on. You can tell that by working out what the sequence is doing. So from one number to the next here, we're going up by 8. Now only the 8 times table goes up by 8 each time, and the 8 times table is 8 multiplied by different numbers. So 8 times 1, 8 times 2, 8 times 3, and so on. If we work out the 8 times table, so 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and 8 times 4 is 32, we can then find out what we do to the 8 times table to get down to our sequence. And to get from the 8 times table to our sequence, we're going to have to subtract 5. So we take the 8 times table and we minus 5 to get our sequence, which is this answer here. Question 5. The first 4 terms of a linear sequence are 7, 11, 15, 19. Same again. To get from each of the numbers to the next, we are adding 4. The only times table that adds 4 each time is the 4 times table. So that's 4 multiplied by some number. I can already see that only one of the answers actually has 4n involved, so that is going to be the correct answer, but let's show why it's plus 3. So the 4 times table, 4 times 1 is 4, 4 times 2 is 8, times 3 is 12, times 4 is 16. And so to get from the 4 times table to the numbers in our sequence, from 4 up to 7, we are having to add 3. And that's the same for all of them. So it's 4n plus 3. Question 6. The term-to-term rule of a sequence is add 8 and divide by 2. The first term of the sequence is minus 24. Work out the next two terms. So the first number is minus 24. To get to the second term, we have to start with that minus 24. We have to add 8. Minus 24 add 8 is minus 16. And then from minus 16, we have to divide it by 2 to get minus 8. So the answer for the second term is minus 8. Now we need to work out the third term. We do it all over again, but this time starting at minus 8. So minus 8, add 8 is 0. And then 0 divided by 2 is still 0. So the next two terms are minus 8 and 0. Part B. The term-to-term rule of a different sequence is subtract 1 and multiply by 5. The third term of the sequence is 120. Work out the first term. So going forwards, I'm going to draw it out a bit bigger here. To get from one term to the next, we first of all have to subtract 1 and then multiply by 5. And that's the same from the second term to the third term. And that comes out at 120. We now need to work backwards, which means we need to go in reverse and do the opposite. So going in reverse, we're first of all going to have to divide by 5 and then add 1. So that's undoing the minus 1 times 5. So 120 divided by 5 is 24, and 24 plus 1 is 25. So the second term is 25. Doing the same thing again, so undoing the minus 1 times 5 by dividing by 5 and then adding 1. 25 divided by 5 is 5. Add 1 is 6. So the first term is 6. Question 7. Work out the next term of this quadratic sequence. 4, 12, 24, 40. In a quadratic sequence, the differences between the numbers, so how much they go up by, increases by the same amount each time. So to get from 4 up to 12, we have to go up by 8. To get from 12 to 24, we have to go up by 12. And to get from 24 up to 40, we have to go up by 16. These differences are increasing by an extra 4 each time. So it's 4 to get from 8 to 12 and 4 to get from 12 to 16. So if we go up an extra 4, this will be now plus 20, making the next term 60. So the answer is 60. Question 8. Here are the first 5 terms of a linear sequence. Work out the nth term. Going back to some previous questions that we had to look at, the nth term is where we're identifying a times table that the sequence is based on, and then shifting that times table up or down until we have this sequence. So first of all, to get from 9 up to 15, we're going up by 6, and that's the same for every single jump. The only times table that goes up by 6 every time is the 6 times table, which is 6 multiplied by some sort of number. 6 times 1 is 6, 6 times 2 is 12, and so on. That's 18, 24, and 30. Now we have our 6 times table, we need to identify what we're doing to that 6 times table to shift it to our sequence. To get from the number 6 up to the number 9, we're having to add 3, and that is the same for every one of these pairs. So our sequence is the 6 times table shifted upwards 3 numbers. So it's 6n plus 3. Question 9. Here is a linear sequence. Work out the nth term of this sequence. So this time our sequence is going down by 6 each time. It's based on the -6 times table. -6 multiplied by a number. -6 times 1 is -6, times 2 is -12, and so on. Once again, we need to figure out what we are doing to get from our times table to our sequence, and to get from -6 all the way up to 46, we have to go up by 52. And that is the same for every one of those pairs. So it's the -6 times table, starting 52 numbers higher. So plus 52. Question 10. Here's a linear sequence: 21, 23, 25, 27. Circle the expression for the nth term of the sequence. Done this a few times now, so this is going up by 2 every time. So it's based on the 2 times table. And to get from the number 2, or any of the numbers in the 2 times table, up to our number in the sequence, we're having to go up by 19. So it's 2n plus 19. So it's this one. A different sequence starts a 2a minus 3, and the term-to-term rule for this sequence is multiply by 2 and subtract 3. The fourth term of this sequence is 35. Work out the value of a. We first of all need to work out the third term. So to get the third term, we take the second term and multiply it by 2. So if we multiply this by 2, we get 4a minus 6. So it's double everything. We then need to subtract an extra 3, which will give us 4a minus 9. Then we get the fourth term, and we do the same. We take our third term, multiply it by 2, which gives us 8a minus 18. And then we need to subtract an extra 3, so we get 8a minus 21. We are also told that this is 35. So that is equal to 35. And we now have an equation to solve. Some number minus 21 is 35. We can find what that number is by adding 21 to both sides to undo the minus 21. So 8a, whatever number that is equal to 56. This is now telling us that 8 multiplied by a number is equal to 56. And to find that number, you can divide by 8. And therefore, a is equal to 7. Question 11. Here are the first 4 terms of a sequence: 4a, 9a, 14a, 19a. The nth term of the sequence is 10n minus 2. Work out the value of a. Just like all these sequences, we are figuring out what we're going up in. To get from 4a up to 9a, we have gone up by 5a. Second thing, if you're looking at our nth term, this first section here is the times table that this sequence is based on. With there being a number 10 there, that's 10 times a number, means that this sequence is based on the 10 times table. The 10 times table goes up by 10 every time, which means that these two things must be equal. 5a must be the same as going up by 10, and so if we divide by 5, we can say that a has got to be equal to 2. There are several other ways that we could have done that question. We could have worked out what the first term was by doing 10 times 1 is 10, minus 2 is 8, and so this first term here of 4a would have to be equal to 8, and if we divide both of those numbers by 4, we get the same answer, that a is 2. Question 12. A sequence of patterns using black squares and white squares. Here are the first 3 patterns. Circle the expression for the number of black squares in pattern n. To work that out, we need to count the black squares in each of our patterns to start a number sequence. So for pattern 1, there are 4 black squares. For pattern 2, there are 6. And for pattern 3, there are 8. This is going up in 2s, which means it must be based on the 2 times table. And the 2 times table starts at the number 2, but our pattern has 4. To get from our times table to our pattern number of 4, we're going up by an extra 2. So it's 2n plus 2. Will the black squares always be even? Tick a box and give a reason for your answer. Well, the 2 times table is the definition of even numbers. So these are all even before we start. If you then add another even number, you will always end up with an even answer. That's because if you start at an even number, I write down a few of these, and you go up an even amount, so if we go up an odd amount, we get to an odd number. We go up an even amount, we get to an even number. And you can replicate that with any of them. So yes, they will always be even because 2n is even, and an even number plus another even number is always even. Question 13. A sequence of patterns uses grey squares and white squares. Here are the first 4 patterns. Work out the total number of squares in pattern 100. So once again, we're going to convert our patterns into numbers using the total number of squares. So that has 6, that has 9, that has 12, and that has 15. This is going up by 3 each time, which means it's based on the 3 times table. The 3 times table goes 3, 6, 9, 12. And so to go from the 3 times table to the number of squares in our patterns, we're going up by an extra 3. So it's 3n plus 3. So pattern number 100 will have 3 times 100 plus 3, which is 303. Part B. Complete the number machine for the sequence of patterns. So we're starting with the number of grey squares and working out the number of white squares. So in pattern number 1, there's 1 grey square. Pattern 2 has 2 grey squares. And so the number of grey squares is actually the same as the pattern number. So we actually only need to focus on the white squares. The white squares, if we write down a number sequence, we've got 5 in the first one. We've got 7 in the second. We've got 9 in the third. And we've got 11 in the fourth. This is going up by 2, which means it's the 2 times table. So we're timesing by 2. The 2 times table is 2, 4, 6, 8. And so to get from our times table to the number of white squares, we're having to add 3. And the final question 14. The diagram shows a sequence of patterns. Work out the number of circles in pattern 6. Well, the number of circles in pattern 1 is 3, 5, 7, 9. So it's going up by an extra 2 each time. So pattern 5 would have 11 and pattern 6 would have 13. Complete the rule below. So if we look at our number sequence, it's going up by 2 every time. So it's based on the 2 times table. So that would be 2, 4, 6, and so on. And to get from our times table to the number of circles in the pattern, we're adding 1. So that gives us an nth term of 2n, add 1. Final question, which pattern number has 51 circles? Well, that's telling us that this must be equal to 51. So we've now got an equation to solve. We can subtract 1 to say that 2n has got to be equal to 50, and then divide by 2 to say that n would have to be 25. And so pattern number 25 has 51 circles. And that is the end of those exam questions. I hope you found them useful.